This session will introduce InSync's iPlanner Axis for the semiconductor industry. iPlanner is an advanced planning solution that runs on SAP's HANA platform and is available on the SAP App Center. It can be deployed on any HANA server, on-premise, your private cloud, or on the InSync cloud. The solution is for operational supply planning and is applicable to both the front-end and back-end operations. Let's start with logging into a semiconductor demo environment. We can log in through any browser, and it will take us to the landing page. This can be configured for each user, and in this case, it is the default landing page. The buttons and menu we see at the top depends on the privileges of the user. The company in this demo manufactures dies, chips, and memory modules. Some of the dies and chips are procured or manufactured by subcontractors. The semiconductor industry has unique requirements that are not common in other industries. Hence, it is critical that the supply chain is modeled correctly. We will illustrate most of these requirements by using iPlanner's network visualization capability. Let's bring up a sample production flow, from a wafer to a finished component at the San Diego factory. The wafer is the most upstream item, so let's move that to the left. And the finished component is further downstream in the production flow, so it will be more to the right. If we expand the wafer downstream, we will see that we have three different dies as outputs. When we expand the finished component upstream, we see that we have three different sourcing paths. Let's connect the assembled component to the dies. And also expand the subcontracting path at the bottom with its associated resource. This will show us the multi-tiered supply chain. Here we are looking at a supply chain of an item with three levels. The circles represent stocking points, and the squares indicate the manufacturing process, and triangles the resources used in the manufacturing process. If we look at the finished component, we have three sourcing options, with the top two being in-house production paths with alternate routings, and then the third, a subcontracting manufacturing option at the bottom. Both in-house options use the same bill of material with the assembly component 1 as the input. The top route is an example of modeling alternate resources within the routing. In this instance, tester 2 is an alternate to tester 1, as indicated by the number 2 on the line. The second route option shows an instance of simultaneous resources, where the production route requires the use of both the labor resource and the K-12 tester resource at the same time. Let's drill into the details of the sourcing paths. We can see that the top sourcing path using Route 1 is the primary path, as it has rank 1. Each sourcing path has attributes associated with it, such as effective dates, lot size, and frozen period. I want to highlight the attribute-based planning capabilities of iPlanner, which we can see in the Attribute Values column. The top option has no restrictions, but for the second option, we see that it cannot be used for any demand that comes from Apple. In the case of the subcontracting option, we cannot use it for any demand orders where the customer is in France. Let's drill down further into the routing for the primary option. Here we see the two alternate resources, and they both have a default yield of 96%, but we also have a yield calendar assigned. If we look at the detail of this, we can see that the yields improve over time as the manufacturing process matures for the product. For assembly component 1, we also have two in-house manufacturing options. In this case, they both use the same routing, but we have alternate bill of materials. The top path uses die 1 as an input, while the bottom path uses die 3. For both bill of materials, we also have alternate inputs within the BOM. Both die 1 and die 3 can be replaced by using 2 of die 2. For the wafer process, we have an example of multiple BOM outputs, known as reverse bill of material. iPlanner's planning algorithm will propagate the demand through the supply chain and will make recommendations to existing orders. It will also create new proposals for procurement, manufacturing, and distribution, including specifying the start and end times for each operation within a manufacturing process. The Messages workbench under Supply and Demand shows all orders and the related information for the orders. Under Order Type, we can see if the order is for a buy, make, or move order. The message tells us what action is needed. Examples are expedite, critical expedite, new proposal, cancel, or move later. Let's look at a specific item, P1 base drive, at the Memphis factory. For this stocking point, we see some expedite messages for existing orders in the beginning, followed by one critical new and expedite. Critical means that a customer will be affected unless we act on it, while a regular expedite means it is just a safety stock violation. We can also see which demand orders will be affected if we are not able to act on the message. In this case, we see 2 demand orders. Further out in the horizon, we see new messages, which are proposals for additional supply. We can also see this information summarized from a different perspective in the inventory report. Here we can see a summary for each stocking point. Let's use an exception workflow to focus on stocking points where we have stockouts and filter the item category for MRAM items. We can see the magnitude of the stockout in the Max Stockout Amount column. Let's select the split screen option and drill down into details for the MRAM CXV item at the Toronto DC. Here we see a supply and demand graph for the year in weekly buckets. We see the starting on hand in the black bar, and a WIP supply order shown in purple, and an open order represented by the dark blue color. The red bars show the demand, and the orange line illustrates the projected on hand, while the green line displays the safety stock target. The first time iPlanner can make a proposal is after the frozen period, which is a few weeks out. iPlanner proposals are shown as light blue bars. We can see there will be a couple of weeks where we're going to be out of stock. We can look at the messages for this item. In this case, there are critical expedites for both the existing order and the first new proposal generated by iPlanner. We can also review the iPlanner plan from a capacity perspective. Let's go to the Capacity workbench. Here we see the utilization for each resource over time, organized by site and resource category. We can use the exception management filters to view only the bottleneck resources. Let's use the split screen option and drill into the details for the module cell resource in San Diego. Here we see a load graph for the resource. The red line shows the available capacity, and the bars display the workloads planned on the resource. The duration of how long the resource is constrained can be managed for each resource, and in this case, it is constrained through the whole planning horizon. We see the workloads divided into the items the resource will work on. We can change this segmentation to be based on other attributes. Let's select Status. Now we see that we have a few WIP orders in the immediate future, followed by released orders, then iPlanner's new proposals displayed in blue. iPlanner easily allows us to have multiple plans to evaluate different options. Let's change to view a graph for multiple plans. Let's first only look at the infinite capacity plan, which will show us the raw requirements. We see that we have quite a few weeks where the work requirements are higher than the capacity. If we add the constrained plan, we can see that this plan does not allow the bars to go over capacity. The iPlanner algorithm will build ahead where possible, as seen here during the November-December timeframe. If we can't build ahead, then it will attempt to build later. Next, let us analyze the plan from a demand fulfillment perspective. We will select Fulfillment and Demand Orders, where we can see all demand orders, their due dates, and how they've been planned. Again, we will use the exception workflow to show only the demand that is going to be delayed. We can use the wildcard filter to just see items with the text DRAM in the item code, giving us a list of the relevant orders. In order to drill down, we will select the split screen option and select the order from Amazon that is delayed by 10 days for 53 units. iPlanner hard pegs all orders so that we can easily drill down through the supply chain and see how an order is being fulfilled. We see that we first need to move the item from the Memphis factory. We can then drill into the makes and buys for the different chips and dies that we need for this DRAM memory module. On the right-hand side, iPlanner will highlight in red to pinpoint where a delay is first introduced. iPlanner also identifies the root cause for the delay in the Reason Code report. In this case, the underlying issue is with the Finish Workstation 1 in the Memphis factory. We can also see a summary of all the reason codes, so let us select the dashboard for root causes. Here we see the leading problems organized by materials and capacity. The chip GX is the main problem maker for chips that we buy. We can see that the Finish Workstation 1 in Memphis is the main issue for capacity, where over 700 orders are delayed due to this resource. If we drill down into the details of the resource, looking at the Infinite plan, we have overages in almost every week throughout the year. If we scroll down to the Constrained plan, we can see the big bar in the unconstrained area, collecting all the workload requirements that could not fit within the constrained time horizon. Let's add a third plan we've created called the Outsource plan. In this plan, we added capacity of a second resource 6 months out to evaluate what impact that would have on the results. This quick scenario planning validates that we need more capacity as many of the weeks are filled to the top. Next, let us review the financial impact of the third plan in the Fulfillment dashboard. Here at the top, we can see the current production plan, where we have demand for $520 million, with $57 million being late on average 11 days. At the bottom in the bubble chart, we see that most of the delay in dollars are in December, where dollar value is represented by the vertical placement of the bubble, and the size of the bubble represents the number of days late. Let us change and look at the new outsource plan. Here we can see the late amount is reduced by almost $50 million, down to $8 million. And in the bubble chart, we see that all the delays after June were eliminated. We only have some delays in the short term left. The outsource plan addresses our fulfillment problems, and this additional capacity scenario will be the recommended solution. In this session, we have introduced InSync's iPlanner Axis for the semiconductor industry. iPlanner is an advanced planning solution that runs on SAP's HANA platform and is available on the SAP App Center.